Reactions and explanations for third group. Number 1. Out of AlOH whole 3, FeOH whole 3 and CrOH whole 3, only aluminum hydroxide is soluble in NaOH solution. That is AlOH whole 3 ppt plus NaOH aqueous. We get NaAlOH whole 4, a soluble complex. CrOH whole 3 may be dissolved in excess of sodium hydroxide. That's why excess of NaOH must not be used. But FeOH whole 3 is not at all soluble in NaOH. Let us discuss the reactions of aluminum ions. The first one is NaAlOH whole 4, the soluble complex, on heating gives NaAlO2, that is known as sodium meta-aluminate. This is soluble compound plus 2H2O. Then NaAlO2 plus NH4Cl plus water. On heating we get AlOH whole 3. This white precipitate reappears plus NaCl plus ammonia gas. The second type of test is take aluminum ions aqueous solution, which can be a solution of the salt directly, then add ammonium sulfide to it. It provides sulfide ions plus water. As shown here in this equation, we get a white precipitate of aluminum hydroxide with the evolution of H2S gas. Directly is take the salt solution or solution containing aluminum ions and to that add disodium hydrogen phosphate, which provides HPO4 2- ions. The two ions combine reversibly as shown here to give a white gelatinous precipitate of aluminum phosphate plus H ions. Then reactions of ferric ions. Number 1, Fe3 plus 3OH minus, that will give you FeOH whole 3, a reddish brown precipitate which is not at all soluble in NaOH solution. Second, Fe3 plus ions directly from the salt solution. To that we can add K4FeCN6. So Fe3 plus 3FeCN6 4 minus. These ions combine to give Fe4 FeCN6 whole 3. This is a complex which appears as a Prussian blue precipitate. But if K4FeCN6 be added in excess, then a soluble, rather a colloidal blue colored solution of K-Fe3 FeCN6 is obtained. Third test for ferric ions can be take the aqueous solution containing ferric ions and to that now add K3FeCN6. That will provide ferricyanide ions. The two ions will combine to give, as shown here, Fe3CN6. That is a brown colored solution. The fourth one is Fe3 plus aqueous. To that we add ammonium thiocyanate. So Fe3 plus 3SCN minus ions will give FeSCN whole 3, that will be in the form of the red colored solution. But this test is not given by iron second. No precipitate or colored solution is formed. Hence, it can be used to make a distinction between Fe2 and Fe3. Finally, reactions shown by chromic ions Cr3+. The first reaction is from the chart, that is Cr3 plus aqueous or salt solution plus 3 OH minus ions forming CrOH3, a greenish white precipitate that is soluble in excess of NaOH. The second reaction is the CrOH3 plus OH ions in excess. We get reversibly a complex, a soluble complex, that is CrOH4 with a negative charge. But this is a green solution. To this green solution, if we add some sodium hydroxide and H2O2, then a yellow colored solution is formed. The reaction equation is 2 CrOH4 with a 1 negative charge plus 3 H2O2 plus 2 OH minus, giving 2 CrO4 2 minus. The chromate ions, they will form yellow colored solution plus 8 H2O. Now, finally, to this yellow colored solution containing chromate ions, if we add lead ions, we get a yellow precipitate of lead chromate. The third test can be take the precipitate of chromic hydroxide as suggested in the chart and fuse it with the fusion mixture. Then the products become 2 Na2CrO4 that being soluble will form a yellow colored solution plus 3 KNO2 plus 2 CO2 plus 3 H2O.